So I wanted to show how to find the derivative of cosine from first principles. We already found what sine was from first principles, so now let's try to do the same thing for cosine. So same basic idea. I'm going to start with the limit as h approaches 0 of cosine of x plus h minus cosine of x all over h. And I really suggest you watch that first video because it's the same basic diagram as before, where I have x and I have h. So I'm just going to go through it a little quicker in this video, where I build my construction like this and start going to label A, B, C, D, E. The cosine of x plus h is equal to OA over OE. What's a little interesting about this as opposed to sine is that that's actually the difference of two things. That's OB minus AB. If you think about what OA is just this first distance here. So I can take OB and then subtract AB from it. So I can then split that up into two different ratios, OB over OE, which is fine. And then AB is the same as CD because they're parts of a rectangle, by the way I constructed it. I left a little bit of space because I hope you notice OB and OE aren't even from the same triangle here. So I'm not going to really use OB and OE in the same triangle. What I'm going to do is multiply by something that connects both of those triangles. OD over OD. Because OD connects a triangle that has OE and a triangle that has OB in it. And same idea with the other one, CD and OE aren't from the same triangle. But if I look at ED, that connects those two triangles. Now, just like in the last video, I flip-flop my denominators around, and I have a wonderful identity for cosine. OB over OD times OD over OE, CD over ED times ED over OE. Take a second, try to think about what I'm going to write next, please. Look at the diagram, see if you can figure out what comes next. Maybe even pause it and think about it for a few minutes. So OB is adjacent to angle x, and OD is the hypotenuse. So this is cosine of x. OD is adjacent to angle h, and OE is the hypotenuse there. And so that's cosine of h. CD is opposite of angle x. Remember, I showed this a little bit more detail in the last video, but this turns out to also be angle x. So CD is opposite, and ED is the hypotenuse for that little triangle. So we have sine of x. ED over OE. ED is opposite of angle h, and OE is the hypotenuse. So we have our identity. So now we can set up the first step of our proof. This becomes cosine x cosine h minus sine x sine h minus cosine h all over h. And of course, we're still taking the limit as h approaches 0. I noticed that these two guys both have a cosine h in common. So I'm going to split it up into two different pieces here. The limit as h approaches 0, cosine h times cosine x minus 1 all over h. And then, what's the other piece? Sine of x, sine of h, and it has a negative on it. Sine of x, sine of h over h. Okay, and in the last video, you can watch again, we used the small angle approximation, which is the idea that if you have a really small angle, the arc length of theta, I'll do it in blue, the arc length of theta is practically the same as the vertical part sine. And for a very small angle, think about the unit circle again, the cosine value is practically equal to 1. So here's what we've got. We're going to use those substitutions. We'll get the limit as h approaches 0 of cosine is, what was I saying there? Cosine is equal to 1 over h times cosine of x minus 1. And then sine is equal to theta. So sine of x times h over h. So this is equal to 1 right there. Now, this first chunk is equal to 0 when you take the limit as h approaches 0 there. Why is that? So let's see here, because as h approaches 0 and oh, that's weird. What did I do wrong? I see my error. Okay, I made a small mistake. I'm glad I caught it. When I wrote this step up here at the top, I wrote cosine of h. This should have been cosine of x. So let's fix that. Now those two terms have a cosine of x in common, and this should read cosine of h minus 1. Sorry about that mistake. So then when I put this as I'll erase a little bit. And I think it's actually really good for you to see, I make mistakes and then try to catch it later and follow it through. It's totally fine to make mistakes as long as you're always thinking about if it makes sense. So then I've got cosine of x times 1 minus 1 over h. So using that small angle approximation idea. And so then that becomes just 0 for that, and the other part just becomes sine, and so we're left over with negative sine of x. So what we just proved is that the derivative of cosine is negative sine. So I knew that I made a mistake because when I was trying to do the limit, I was dividing by 0, and I was trying to say that that ends up equaling 0. Well, dividing by 0 doesn't really end up equaling anything. So I knew I had to have some mistake, and I had just written down this step up here. I just written that down wrong. Everything else was right. So sorry about the mistake, but I think it's honestly good to see it. And please let me know if you have any questions or comments. Thanks.